All right, I'm going to make a video over all of Mod 13 to help you out with the quiz this week. All right, let's roll. All right, the first one here, we're just looking to write the ratios. So sine t, that is opposite over hypotenuse. So look to see where you are here. So this is t. Opposite would be straight across, and then hypotenuse is always straight across from the 90-degree angle. So sine is 6 radical 2 divided by 19. Again, that's opposite over hypotenuse. Then we have cosine of t, and cosine is adjacent over hypotenuse. So those are those two sides. So adjacent is the one that's right next to the angle. So that's 17 and then over 19. And then we have tangent. So tangent of that same angle is opposite over adjacent. So that is 6 radical 2 divided by 17. Okay, we're looking to solve this. Now, we have to solve for x. So we're going to say that we have the adjacent side here, and then we have the hypotenuse, because it's straight across from the 90-degree angle. So adjacent over hypotenuse is cosine. So we're going to say cosine of x, we don't know how much that is, equals 9 over 18. Now to solve for x, we're going to have to do the inverse cosine. So we're going to do inverse cosine of both sides. So if we do that, that will get the x by itself. So we're going to do x equals inverse cosine of 9 over 18. So that's just something we need to type into the calculator. So I'm going to do that. So second, you have to, if you use the nice TI-84s, you do second, the blue button, and then cosine. So, and then we got 9 divided by 18. And I want to make sure that I'm in degree mode. And I get 60 degrees, exactly. All right, we're trying to solve for x. So if you look at the angle measure, it looks like we have the side that is opposite that angle measure. And then we also have the hypotenuse. It's across from the 90-degree angle. So pick the trig function, trig ratio that is for opposite over hypotenuse. So that's sine. So that sine of 46 degrees is equal to opposite over hypotenuse. Now, whenever the variable that you're trying to find is on the bottom, you really need to do it in 2 steps. So we're going to multiply by x first. That's going to cancel out the x's on the right side. And that gives you x times sine of 46. Then you want to divide by sine of 46 because we're trying to isolate the x. And then that is just something we type into the calculator. So we're going to go, I usually do alpha y equals because I want it to look like a perfect fraction, but either way you just do 11 divided by sine 46, and I got about 15 point, it says we're supposed to round to the nearest degree or tenth, so that would be 15.3 is what this one is. It's 15.29, so to the nearest tenth is 15.3. Okay, if you look at this one, we're trying to solve for the x degrees here. So that's opposite and that's adjacent. So opposite over adjacent is tangent. So tangent of x degrees equals 25 divided by 13. Then we're going to solve for x. So that's going to be by finding the inverse of each of those, of each side. So x is equal to inverse tangent of 25 over 13. And so x is approximately, so let me type that in, inverse tangent alpha y equals 25 divided by 13. That is 62.5 degrees. All right, this one, let's see, we want to find x. So we don't really have angle measures, so we just have a side length here. So what we can do is the Pythagorean theorem. So we have 9 squared plus x squared equals 12 squared. So the two legs, you square those and add them, and that equals the hypotenuse squared. We know the Pythagorean theorem, hopefully. A squared plus b squared equals c squared. I'll just write that. Okay, so let's work it out. So we got 81 plus x squared equals 144. Then we're going to solve for x, so we're going to subtract 81. So 144 minus 81 equals 63. So then we need to take the square root. So we're going to take the square root of both sides to solve for x. So square root of 63, and we're supposed to round it to the nearest tenth. So we'll say that's about 7.9. Okay. Next. All right, so this one, you could just kind of look to see, where you're at as far as the angle measure as it refers to the other angles, or to the other sides. So you can tell we have the side that's adjacent, it's right next to it, and then we have the hypotenuse because it's straight across from the 90-degree angle. So adjacent over hypotenuse is cosine. So that's cosine 55 is adjacent over hypotenuse. And again, this one has the x on the bottom, so it's a two-step. So multiply by x first. So then that's 12 equals x times cosine of 55. And then we're going to divide by cosine of 55. So x is approximately, and then we just type that in. So I like to do alpha y equals, so 12 divided by, whoops, messed that up. So 12 divided by cosine 55. All right, looks like 20.9. So hopefully you're doing this on the calculator too, just to verify that it's working for you. All right. This one, we're looking for the angle measure again. So it looks like we have opposite, and then we have hypotenuse. So this is sine. So we're going to do sine of x degrees is equal to 23 over 25. Remember, when you're looking for an angle measure, you're going to do inverse of whatever that trig function is. So x is equal to inverse sine of 23 over 25. So x is approximately, so I'm going to do second inverse sine, 23 divided by 25, 66.9 degrees. All right, this one, we have this angle measure, so that's we have the side that's opposite that angle measure, so that's opposite. And then we have adjacent. So we don't have the hypotenuse because that's the one across from the 90. So we're going to do opposite over adjacent, so that's the tangent relationship. So tangent 62 degrees is equal to 12 over x. This is again a two-stepper, so we're going to multiply by x first. That's going to cancel it out on the bottom. Then we're going to have 12 on the right-hand side, x times tangent of 62 degrees. And then we're going to divide by tangent of 62 degrees. So x is about, and then we just type that in. So that would be 12 divided by tangent 62, 6, let's see, 6 point, I would round it to the nearest tenth, so it would be 4, 6.4. Okay, special triangles. So we have the 30-degree leg, and they say that that's 1. So anytime you're going from the 30-degree leg to the 60-degree leg, you always just have to multiply by radical 3. Now, radical 3 is obviously bigger than 1. It's 1 point something. So that's why it's going to make it a little bigger across from the 60-degree leg. So this y would be equal to 1 times radical 3, or just radical 3 is great. And then the hypotenuse is always twice as big as the 30-degree leg. So if this is 1, then we know that x is 2. So double that. All right, this one we have the hypotenuse. So we have the hypotenuse. The next best thing is to go to the 30-degree leg. You can see it's across from the 30, so that means it's half of the hypotenuse, so that's 4.5. Then if you want to find the 60-degree leg, that's always the 30-degree leg times radical 3, so that's 4.5 times radical 3. Okay, this time we have the 60-degree leg. So what you have to do is, if you want to find the 30-degree leg, instead of multiplying by radical 3, you divide by radical 3. So that's 25 divided by radical 3, which is an okay answer. It's not a simplified radical. So we rationalize the denominator, which means we multiply by radical 3, top and bottom. So we multiply by radical 3, and that turns out to be, final answer, that would be 25 radical 3, and then on the bottom, the radical 3 times the radical 3 becomes radical 9, or square root of 9, which is a positive 3. So that's your final answer there for at least that letter. And then for the hypotenuse, it's always double. It's always double whatever the 30-degree leg is. So if you double this, that just means you multiply the top number by 2. So that would be 50 radical 3 divided by 3. Okay, this one is a special triangle. It's an isosceles right triangle, which means that these two angles have to be the same, and they're both 45 degrees. And then what you have to do here is whatever the legs are, you just multiply them by radical 2 to get the hypotenuse. So this is just 8 radical 2. There's no calculating or anything that you need to do. Okay. Same thing here when we have 45, 45, 90 triangle. The hypotenuse is bigger, And so if you're working backwards, instead of multiplying by radical 2, which actually makes it bigger, you want to make it smaller. So we're going to do 28 divided by radical 2. And so that's an okay answer, but we want to rationalize it because we want to get rid of the radical on the bottom. So we're going to multiply by radical 2. Then that will give us 28 radical 2 divided by 2. And then we can still reduce a little bit. So we're going to do 28 divided by 2. And so that cancels out a little bit. So that's going to be 14 radical 2 is the best answer. All right, this is another special triangle. It looks like what we have here is the 14, which is across from the 60-degree leg. So that means if we want to find x, that's the hypotenuse, we must first find the 30-degree leg. So what we're going to do is we're going to divide by radical 3 again. So, and then we would want to rationalize it. So let's go ahead and multiply by radical 3 over radical 3. So that means this would be 14 radical 3 over 3. Now this is the 30-degree side, that's this side here, but we're trying to find the hypotenuse, and the hypotenuse is always double whatever the 30-degree side is. So now we need to multiply this by 2. So multiply by 2, and when we multiply the top by 2, that gives you 28 radical 3 over 3. So the rest of the, everything stays the same. You just multiply the top by 2. Okay, this one we have a couple sides. We just have to find the third side, so we're just going to use the Pythagorean theorem. So we've got 13 squared plus 25 squared, that equals the hypotenuse squared. All right, so let's multiply these out. So we got 13 squared is 169. We got 25 squared, that's 625, and that equals x squared. So x squared equals, let's do 625 plus 169, so that's 794. And then we want to solve for x, so we're going to take the square root. That's how we get rid of the squared. So x is about, it's the square root of 794. So square root 794, 28 point, we're supposed to round this one, looks like, well, let's see, let's round it to the nearest tenth. So let's say 28.2, looks like. Okay, so same thing here, we're going to do the Pythagorean theorem, so it's going to be x squared plus, make sure you know that whatever's across from the hypotenuse, or whatever's across from the 90-degree angle is the hypotenuse, and it's the one that's by itself. So x squared plus 23 squared equals 25 squared. So x squared plus, let's do 23 squared, that's 529. And then 25 squared, that's 625. Then we're going to subtract the 529. So 625 minus 529, 96. Oh, that's my phone. I'm going to have to wait on that. It's probably my realtor, but I got to wait on that. All right, so I'm going to take the square root. So x is about square root of 96, which is 9.8. So 9.8. All right, so we get to an application problem. All right, so we have this forest ranger. He's at a tower. So let's say the tower is 20 feet tall. So he's in the tower up here. And then he spots a fire at a 13-degree angle down. So the way you do it is you draw, he's looking down at the fire. So let's say this is a fire. Okay. So he sees a fire. And then let's put the angle measure in there. So let's put 13 degrees here. So that's 13 degrees from the horizontal. Again, this is the horizontal. Then if we make a triangle out of this, we know that this is 13 degrees too, because these are alternate interior angles, like this. These are parallel, and so that's 13 and that's 13. The question is, how far is the fire from the base, so that we're looking for that. So you can see after you draw a good diagram that we have opposite and adjacent. So that's tangent. So we're going to say tangent of 13 degrees is equal to 200 over x. We're going to solve for x. So we're going to multiply. It's a two-stepper. So we're going to multiply by x. So that'll be 200 on the right. This will be x times tangent 13 degrees. And then we're going to divide by tangent of 13 degrees. And so x is about, let's see what we get here. So 200 divided by, keep doing one divided by, I don't need it. Okay, so tangent 13 degrees, 800 and, what does it say to round to? Nearest foot. Okay, so it's about 866 feet. All right, we're almost getting there. All right, we got a little penguin. Okay, the little penguin is 50 feet below the surface. Okay, so there's the penguin. He's right here, and let's say this is the water, like that. Okay, he spots land at a 25-degree angle above the horizontal. So again, horizontal is, the left and right. So he spots it 25 degrees above the horizontal. So because that's 25 degrees, this is 25 degrees, because they're alternate interior angles again. And so he spots land right here. Okay, then the question is, how far must he swim in order to reach the land? Well, he just wants to go straight to the land, just straight along, that line. So we set up a nice little triangle. You can see my nice triangle there. And so we just kind of figure out what we have. So we have opposite, and then we have hypotenuse. So that is sine. So sine of 25, that's opposite, which is 50, over the hypotenuse, which is x. And then we just solve for x. So that's a two-stepper because the variable's on the bottom. So that's going to be 50 equals x times sine of 25. Solve for x. Divide by sine of 25. So x is about, let's see what it is, 50 divided by sine 25, 118. We're supposed to round it to the nearest. What do we got on this one? Not sure on that one. I'll just say 118.3 feet. Okay, or nearest foot, 118. Okay, now the area of a triangle. So super easy to find the area of a triangle. So area, and this works really well if you're given, side angle side. You can use this for the area because you don't need the height of a triangle. Normally you need the 1/2 times the base times the height. Well, this is a little bit different. This is area equals 1/2, and then it's times the side lengths. So 1/2 times 12, and that's, actually, let me put the units in there. So 12 centimeters, and then we got the 9 centimeters. Oh, it ran out of room. And then times sine of the angle between them. So sine of 68. And then you just type all that in the calculator. So angle, or the area is about, so let's see, 1/2 times 12 times 9 times sine of 68. I got 50, let's say 50.1. And this is, because it does have units, so let's do centimeters squared. All right, how are we doing? Let's see. Oh, okay. So we got this guy. This one's pretty solid. All right, so what we need to do first is we need to plot these points. Okay, so let's plot them. We got 1, 2, 3, 1, 2, 3, 4, 5. So there's, it's not letting me. Come on, you little rascal. There. Okay, so that's J. That's 3, 5. Okay, then we have K, which is negative 3, 5. And then we have L, 3, 1. Okay. So, let's see what we got here. So we make a nice triangle. All right. And then we basically need to find everything. So find all the side lengths and the angles. Okay, so it's going to be, you can tell it's a right triangle. So I'm going to go ahead and say that's a right triangle. Oh, it's not letting me write. Okay. So then what you can do is just count. So just count from negative 3 to 3, and that's 6 units. So we just count. And then this one, we go from the 1 to the 5, so that's 4 units. So, yeah, this little rascal thing. Híjole. Come on. Okay, 6, 4. Okay, and then we could use the Pythagorean theorem to find the hypotenuse. So let's do 6 squared plus 4 squared equals the hypotenuse, which is KL squared. So let's do that. So we got 36 plus 16 equals KL squared. So 52 equals KL squared. So KL is the square root of 52. So we'll list that, square root of 52. And then all we need to find now are just the angle measures. So we can use a lot of different things for this. We could use any of the trig functions, but let's say we want to find angle L. We could use the 6 and the 4 because that's opposite over adjacent. So let's do tangent of angle L is equal to opposite, which is 6 over 4. And that means if you want to find the angle L is inverse tangent, because remember how we do the inverse to figure out the angle? So that means that angle L is about, and then we can just do that on the calculator. So we could do inverse tangent 6 divided by 4, and that's about 56.3, and that's degrees. All right, now we could just do 90 minus that, really, to figure out the other one. So let's go ahead and just do that. So that means that angle K is about, 90 minus 56.3 degrees. So 90 minus 56.3, so 33.7. Oops, let me kind of write that better. So this is angle K. All right. And I think that might cover it all. Let's see if there's anything else. Oh, darn, it says the nearest hundredth. Oh, booger. All right, let me try that again. So hold on, inverse tangent, 6 divided by 4, 56.31. All right, let me fix that. 31 degrees. That means 90 minus, fix that, oops. 31 degrees. Okay, so that means that this would be 90 minus 56.31. That, messed that one up. 90 minus 56.31, that's 33.69 degrees. Okay. All right, let's see if I have any more. That might be it. Oh, yay. Okay. Good luck. Awesome. Good luck.